Hello guys, now my name is Maniteja. I am from CSC AML A section. Now my topic is about the projection matrix with respect to the symmetric matrix. Now we will see some introduction about the projection matrix with respect to the symmetric matrix. Now we will see some basic definition about symmetric matrices. In linear algebra, a symmetric matrix is a square matrix that is equal to its transpose. Formally, because equal matrices have equal dimensions, only square matrices can be symmetric. Here, the square matrices means the I cross j value is I equal to j. The I cross j is the order. The order should be same as I equal to j. Here, the A transpose is the columns and rows are interchanged. Then that matrix is called A transpose matrix. Here let assume A is some matrix and the transpose of A is A power t. That means the transpose of A matrix. Now we will see some condition of symmetric matrix. This is the condition of symmetric matrix. The matrix is said to be symmetric matrix when a matrix is equal to its transpose. The, that means a matrix when its rows are interchanged with columns and then we get the same matrix, then it is called the symmetric matrix. Here we can see one example of symmetric matrix. Let's take B equal to 1 matrix. Here the first row is 2, 3, 6 and the second one is 3, 4, 5 and the third one is 6, 5, 9. Then the transpose is B power t when the columns are interchanged with rows. So then also we can find the same matrix, that is first row is 2, 3, 6 and the second one is 3, 4, 2, 3, 4, 5 and last one is 6, 5, 9. We can find the same matrix. That means this condition is satisfied, that is B equal to B transpose. Now we will see some basic definition about projection matrix. The projection matrix is a square matrix. Let us assume P is called an orthogonal projector or projection matrix. If it is a it is both idempotent and symmetric, that means idempotent means P square equal to P and symmetric is P transpose equal to P. If a matrix, if a square matrix satisfies this condition, then it is called projection matrix. For a given matrix X of order n cross P, where n is greater than or equal to P, where X transpose into X is non-singular. Non-singular means it is it ha its det is not equal to 0. That means X transpose into X is a non-singular means its det is not equal to 0. Then we can find P of X, that means that this equation, and Q of X, that is equal to 1 minus P of X, that is a symmetric one, we can find by using these equations. Now we will see some properties about projection matrix respect to the symmetric matrix. Now, this is the first property that says that a matrix X is a solution to a consistent linear system Ax equal to B in X if and only if X into A inverse B plus 1 minus A inverse into A into Y for some matrix Y. It states that X is a solution to a consistent linear system of Ax equal to B. Now, the second one is let W be an n cross n symmetric non-negative defined matrix where WA is a symmetric and A is idempotent, then LA equal to LP AW. So it states that a, a matrix W is a symmetric non-negative defined matrix. If W is symmetric, then A is idempotent. Then this condition is satisfied automatically. And the next one is let W be an n cross n symmetric non-negative defined matrix. If A transpose WA equal to WA, then this LA equal to LPAW condition satisfies, which means the above condition A inverse WA equal to WA, then this condition satisfies. And the next one is when W represents an n cross n symmetric non-negative defined matrix for any n cross p matrix, let's say X, and any n cross q matrix, let's say Q, such that C of u equal to C of X, then PUW and into PXW equal to PUW. This, these two conditions satisfy when C of u equal to C of X. Now we can see these conditions which are more relevant about the given conditions earlier. So by these conditions we can easily solve the problem without any hesitation. Now the next one is let W represent an n cross n symmetric non-negative defined matrix. Let Y represent an n-dimensional column vector and let Y represent a subcase. Define Z to be the projection of Y on U when the inner product for n into R is taken to be the bilinear form X inverse WY. The symmetric non-negative defined matrix is the set of eigenvalues of A and the set of eigenvalues of AT are equal. Here the A and T are separate matrices. An n cross n matrix B is called a non-negative definite if for only any n-dimensional vector x we have xtb is greater than 0. Here the eigenvalues of A into t is not is non-negative. And the next one is let X represent any n cross P matrix and W any n cross n symmetric non-negative defined matrix. Then LPXW equal to LX, which states that if an X, if a matrix X and Y are symmetric and non-negative definite matrix, then this condition compulsorily satisfies it. So, by this, there is another condition. If when it satisfies this first condition, then the second condition automatically satisfies. That is, Lx into xwx whole whole inverse x transpose into wx equal to Lx. This is an formula for the symmetric non-negative definite matrices. This is an easy way to find some solutions of symmetric non-negative definite matrices. This is about matrices and the projection matrix with respect to the symmetric matrix. I hope you all have understand about the topic is the projection matrices with respect to the symmetric matrix. Hope you have got some knowledge. And there are also many ways to find the projection matrix with respect to the symmetric matrix. There are many methods and theorems based on this topic, so we can discuss it later. Thank you.